now. So if you're seeing my screen, you're seeing question 3,
Yes,
and you're in some sort of a business calculus class. Is that right?
I am.
Okay. All right. So the consumer demand for some dumbbells is given by this equation, where P is the price and Q is the demand in weekly sales. Find the price. I'm so sorry. My screen just stopped sharing. Um, hmm. Well,
I can still see the problem.
yeah, this tablet I'm using, I want to make sure. So are you seeing my screen still?
Yes, I can
Okay.
see the problem.
Okay. Hopefully this just works and I don't have a bigger issue. So um, you want to maximize revenue. So revenue is price times quantity. And in this case, P is the variable. And then price is the variable. So Q is what's given here. So that's the 87 minus 2P quantity squared. And you're trying to figure out what maximizes this. So you need to take a derivative. That's one option, or you can just graph this. Now, do you know if your exam is like are you trying to just get the answers, or are you trying to like learn how to do it, like anything in between? What's kind of the goal here?
It's the derivative. That's what we've been learning.
Yeah, and that's the right way to do this, but this is a product rule, so it's it's a little more work, but that's fine.
Oh
Um,
yeah. That's we've also like learned product rule and stuff like that.
Great, great. So the product rule here, it's P. This is your first term, so it's you probably saw this in class, like U V prime plus VU prime, something like that. When you have a U times V, maybe
Mhm.
the
Yeah.
product. She thinks okay. So it's P times the derivative of this. The derivative of this is 2 times 87 minus 2P to the power of 1. First you use power rule, then chain rule. So you multiply by the derivative of the inside function. The inside function is -2 plus the second thing right here, this 87 minus 2P squared times the derivative of P, which is 1. So let me actually just rearrange a little bit so it's a little bit cleaner to look at. This is your derivative here, and then you set this equal to 0.
Okay.
So to do that, you can factor out anything that's common to both. So there's this is common to both. So you can factor out an 87 minus 2P from both. So from this first one, this one's more complicated than most of them. What you have left over is P2 and -2, so that's -4P plus 87 minus 2P, because you have two of them here equal 0. So you set each of these equal to 0. So this 87 minus 2P on the outside, you set that equal to 0. And then you set this -4P plus 87 minus 2P equal to 0.
Okay.
Is there anything I've done that is not clear? Because we should look at it again right now if it's not.
No, I understand what you're doing. For for the last part, when you said -4P plus 87 minus 2P, can you combine the -4 and then 2, or not yet because it's still in parentheses?
You can drop the parentheses because there's a plus here.
Okay.
So like I actually have more to do here. On the left here, if you're when you're solving this one, P equals 87 over 2. And here it's 87 minus 6P equals 0. So P equals 87 over 6. And one of these is right, because the domain, there's probably like, yeah. So from here, I don't know what to take. It's like the how do we want to do this? I almost want to show you graph just because I think it will help, but it's not the I know you can't use the graphs, but let me just try to do it anyway. I'm pretty sure this question doesn't come up on your exams, at least in the past, but it is kind of worth knowing
Yeah.
all these things. So sorry, let me get to where I can make this a little bit better. The Y 0. Okay. So sorry, just get this cleaned up, snip this in, show you. All right, so what I've done here is and I'm going to snip this into here is as I've graphed the original function. So if you didn't have to show your work, like this would be the faster way to do it. You just graph and figure out, where the mins and maxes are. So this point right here
Mhm.
is 87/6. This point right here is 87/2. Now, one of the things that maybe you covered or did in class is that the domain of this function actually only goes from 0 to 87/2. So you actually wouldn't include that point. And that's why it has to be that one.
Okay.
And you can see that it's a max right there. Let me grab that point. You need it to 2 decimal places.
Let me look really quickly. To the nearest cent.
Okay, so 87/6. Let's see here. It's exactly 14.5.
Okay.
Okay.
Okay, cool.
Again. Not again. Something with today's been. I have to redo a screen thing here. Okay. I'm sorry for the technical issues here. They're all on my end. Is that okay? Can we move on to a new question, or would you like
Yes.
any more explanation of that? Okay, so let's go to question 4. Oh, I'm sorry. I usually do these in order. Let me go back to 2. Let's see. They sent like this. Okay. So here's question 2. Let's make it a little bigger so we can see it. All right. So you found this. So at what price should the tissues be sold to maximize the revenue? There's 2 ways to do part B. One way is to figure out where E equals 1.
That's the way that we're supposed to be taught how to do it, or that's
Okay.
the way we're doing it.
Okay. So then to do this right, you have your elasticity of demand is minus P over Q times dQ dP. Does that sound right?
Yes.
Okay. So you have minus P over 94 minus P squared times 2 times 94 minus P times -1. And then this cancels with that one. So you get 2 P over 94 minus P, and you're supposed to set that equal to 1. Does that look similar to what you did?
Yes.
Or at least got for that, because sometimes they ask you for the demand or the elasticity function. So you're just solving this equation. They call this a butterfly. Sometimes they cross multiply. 2P times 1 equals 94 minus P times 1. 2P equals 94 minus P. 3P equals 94. So P equals 94/3.
Okay. I guess I'm just not understanding, or I'm how to do like the equation. 'Cause the way
You're talking about this one up here?
yeah, like
Okay.
how you got the 294 minus P times -1.
Yes. Okay. So there are 3 things needed here. There's P,
Mhm.
Q, and dQ dP. So like 1, 2, and then 3. So number 1, P is just a variable.
Okay.
Like that's always P. Almost always it's just P. Okay. Now Q is usually given. It's a function. In this case, it's right there. There's Q. But you just want the right hand side. Like you want like what Q equals.
Mhm.
So that's why I wrote 94 minus P squared here.
Yes.
Okay. And then the third piece is the derivative of Q. Okay. So the derivative of this 94 minus P squared. So that's power rule followed by chain rule. So like the 2 comes down. So to find Q prime or dq dp, the 2 comes down,
Okay.
94 minus p, like you keep the inside function, power of 1, and then what's the derivative of the inside function? It's just negative 1.
Oh, because the P, it just turns into a 1 and the 94
Exactly.
is 0. Okay.
Yes. Yeah, it's really 0 minus 1, but at some point you stop writing the 0.
Okay. That makes more sense.
And then almost always you get a cancellation, and then and then this happens.
Okay.
So so what we did is we set that e function here equal to 1, and that's at this top of this curve here kind of thing. And then you just solve it for p, and you get 94 over 3, and get that as a number. What do we got there? We got 31.3333.
Okay. Yeah. Okay. Yeah. I guess like just finding the derivative was kind of confusing, and I
Sure.
was
Yeah.
having a lot of trouble, and that's why I kept on getting all the wrong answers.
Yeah. This is where most students start to struggle in this course, because it's all of a sudden it truly is calculus. You have to be able to be consistent with your derivatives. And I'm sure you can do it. You've gotten this far. It just, if it's unclear, we can look at it again. So part C, you have to take that value that you just found, that p value. So p is 94 over 3, and you put that back into the original to get q.
Okay. The original.
Yes. There's quite a few parts to these problems, and that's just something you're going to have to get used to. Like there's several steps for each
Yeah.
one of these. So the answer I get is it says rounded nearest whole number is 3927. That.
Okay. Let me see.
Now it looks like we're going to do more of these for the other problems, more of the finding E. So you'll get much more comfortable with it.
Yeah.
Is there anything in this question you'd like me to go through again, or can I move to number 4?
No, I understand this question.
Okay.
Yeah.
Number 4 is going to be good to do next, because you're going to find E. I'm going to show you how to do it, and hopefully it becomes clear, because I'm sure you got a test coming up. And
Yeah, I have a test on Thursday.
all right. Okay, they almost always give you Q, like,
Okay.
because if you write out the formula for E, it's minus P over Q, which means you need Q, dq dp. So currently you already have two pieces. You have the P and you have the Q. Like this is your Q. So right now your E is minus P over minus 2P squared plus 33P. Now you have to take a derivative of this thing right here. And the derivative of this is just power rule.
Okay. So that would be negative 4p times 2p squared.
Just negative 4P for the first one. So your Q is minus 2P squared plus 33P. So your derivative, it's just power rule. You bring this 2 down and you multiply this negative 2 by 2.
Oh, okay.
And then you subtract 1 from the exponent.
Got it. So it's negative 4p
Yes.
plus 33.
Plus 33. Perfect. Okay.
Okay.
Great. Now that's here. And let's see. So why didn't it like your answer? I'm trying to think back to like what this problem's, because I've seen these so many times, could be a sign thing.
Well, and then you have so
Like if this goes in here, which is kind of what you did here, it becomes, sorry, I'm running out of room here. So I'm gonna write it down here. It becomes 4P squared positive minus 33p. So I'm already seeing a potential sign error there, like
Yeah.
that should be plus, maybe minus 2p squared plus 33p. But this is very important. Do you see how every term has a p in it?
Yeah.
That means you got to factor a p out of everything.
Oh,
So,
okay.
so this becomes 4p minus 33 over, and that's probably the bigger issue, minus 2p plus 33.
Okay. Let me just change that really quickly.
Let me know if that is not correct, or
Yeah, so I put in 4p minus 33 over 2p plus 33.
it should be negative 2p there on the bottom.
Oh, okay.
Now,
That's why.
as you know, even one little thing, just web
Yeah.
assign says, nope, you're completely wrong. And
Okay, yes, that's correct.
great. So now part B. So compute the elasticity of demand if the price is set at $9 per shirt. So they're telling you P equals 9.
So would you just plug that into the equation?
Yes, exactly. And round to 2 decimal places. I assume you're allowed to use a calculator because that's what's going to be required on the exam.
Mhm.
If you need any guidance on how to enter the calculator, let me know. I'll do it also here and can compare our results. So I get actually a pretty nice number here. I get 0.20.
Yes, me too.
Great. Okay, so this one is always a little bit the demand is going, I want to say it's going up by, it's usually this number goes here. But I think there was always some confusion about whether this is up or down.
Yeah.
And I think it depends on where E equals 1. So
On the graph.
yeah, this is one of those finer points, I guess. Like I don't, we're gonna dilute what we're trying to do today if we go into this discussion, but I think you get 2 guesses on this, but just confirm that this number, I'm pretty sure this number always goes here because that is what it's meant by that.
Yeah, let me check real quick. Yes, it is.
Great. Okay, so either ask your instructor, well, if we have time at the end, we can try and dive into that more. But C is like we did in the last problem. C is setting E equal to 1. That's where you maximize your revenue.
So you do the 4 over p minus 33, all that over.
Exactly.
Okay, that's 1. All right.
And it actually is a nice equation because when you cross multiply here, butterfly, whatever you want to call it, you end up getting just a nice linear equation that you've seen many times before. 6p equals 66 and p equals 11.
Okay, and then you just plug 11 back into the first equation, right?
We just want the price, I think. Let me just scroll up here. It just wants the price, so that's just 11. If they wanted the quantity, you would put that back in.
Okay.
But they just want the price. Do you see how much the physics club charge?
Mm-hmm.
I know in the last one we put that number back in, but
is that what, because they were asking for the revenue?
Here they're asking for how many cases, the quantity.
Okay.
Are you a business student?
I am. I'm a sports business.
Sports business. So you will care about these things like how much money are we charging, and then how many are we charging, so that we can, make however much you want to make.
Yeah.
And some of this gets lost in the middle of these questions, but this is actually very useful for, if you were even thinking about doing some sort of business right now, because how much you charge times how many units you sell is very important.
Mhm.
Right, is it okay if I move on to number 5?
Yes.
I'm sure there's some overlap, meaning that we're going to find E again, or we're going to use E to find something, or yeah. Okay, find the price elasticity of demand when the price is set at $36 per copy. Okay, so we'll do this the way that we've been doing the previous problems, which is we need to find E. Minus P over Q times DQ dP. And if you don't get a reference sheet, try to write the formula down each time you do it.
Mhm.
That'll help. So your P is your variable. So you're good. Yeah, I got my P. Q is given. Q is right here. 444 minus P quantity squared over 100. Now we got to find the derivative. We need the derivative of this. So let me just slightly rewrite this. Q equals 1 over 100, 444 minus P squared. And the reason I did this way is I just want to remind you that this constant comes along with it when you take the derivative.
Okay.
So try and find the derivative here, and then I'll write out the derivative, and you can check your work with me.
Oh, so this would be like the product rule and the chain rule, right?
It's actually just power rule because this is a constant. So like imagine that wasn't there. It's a power rule followed by a chain rule, no product, because this isn't actually the 1 over 100 is not a function of that.
Okay. So it would just be 1 over 100 times 2 parentheses 44 or 444 minus P. Oh wait, just kidding.
That's right. This is good
That's
so
right,
far. This is good. And then there's a little more. What's the derivative of the inside function?
and then that would be 100 times 2 to the negative P. No,
Yes.
yes. Wait, wouldn't it just be 1?
Times -1. Sorry, -1.
Yeah. Okay, so then that's just
Okay.
-2 over 100.
Which, yeah, and let's, I mean, you can simplify, it depends how comfortable you are with like all of this, because this one's pretty messy. So I just took this and brought it down here. So the derivative you just found is dq dp. Let me just box that in.
Okay. Why did we take, where did the 444 minus P come from?
The power rule. So the power rule
Okay.
says to keep the inside function.
Okay.
If you haven't heard it that way, that's kind of the terminology I like to use to remember that you have to hold something with it. Okay, now to be clear, you don't have to simplify this because it doesn't ask you for it, but you might want to get in the habit of doing it, especially if you're going to use it a bunch of times, which we are. So like for part A, you just could put 36 in for P and be done, but there's a lot going on here. So let me try to help here. And this is all algebra at this point. So if your algebra isn't strong, just try to follow along here. This 100, because it's in the bottom, you can actually bring it up to the top. So the reason is because you can multiply the top and bottom by 100. So this becomes minus 100p over 444 minus p squared times minus 2 over 100. And then this 444 minus p, it's still in the numerator here. So this is just a rewrite step.
Mhm.
And now you see some cancellation. See, that cancels with that. The 100 cancels with that 100. And kind of like the last problem, you get something kind of nice here. You get negative negatives, that becomes positive 2p over 444 minus p.
Okay. Okay. Yeah, I see how you got that.
Great. So this is your E. And like in the previous problem, you had to actually submit that, but that is your E. Now that's not the answer to part A. Part A is use your E and see how price is 36.
Mhm.
You're going to substitute that in down here. So 2 times 36, 444 minus 36.
Okay.
And does it say 2 decimal places?
Yes.
So these numbers don't mean a lot. But what I would share, was your first exam on WebAssign, or was it in this format?
No, it was actually in person.
Okay. Well, like this number doesn't mean anything. So sometimes you can talk yourself in or out of whether you did it right, because like if you got this problem again, it would be in this, close to this number.
Mhm.
But you just have to trust that you put it in the calculator and so on. Okay, so that's part A. Any questions on that? Anything you want me to go through again on that?
No, I think I'm okay.
Okay, so part B, the price at which the publisher should sell the books to maximize weekly revenue. So that's setting this equal to
1.
1. So see if you can do that and come up with the correct answer. So 2p over 444 minus p equal to 1. See if you can get the right answer there. And if you're down to your last submission, I can check it before you submit it, but I think you can do it without my help.
I got 148.
Go ahead and try it. I don't have my calculator out.
Oops.
Seems reasonable.
Yes.
Great. So that's the price. If it asks for the quantity, which it does, see how I'm sorry, it does not. It asks for the revenue. So the
Mhm.
revenue you get, revenue is price times quantity. So you have the price now.
Yes.
The price is what you found in the previous part. Where do you get quantity from? Well,
That
they give you it right here. So you have to go back to the original equation and find quantity. So part C, you're going back to Q equals 444 minus 148 squared over 100. You get that number, and then revenue is price times quantity. So it's 148 times whatever you get there. So and I said round to the nearest number. So P equal 148.
So that's Q, and then you multiply that by P, right?
Yes.
And the price is 148. Okay.
So for Q, I'll write out some of these intermediate numbers. It's that.
Mhm.
And then this.
Yes.
So you round to the nearest whole number, I think. So 672. Sometimes it says like nearest 100 or something weird, but it says nearest dollar. $129,672.
Perfect.
Okay, so the next two questions you're done with kind of elasticity. So if you have any questions or anything you want me to review again about the elasticity of demand, now is probably a good time because we'll transition into something slightly different.
Yeah, I think I pretty much get the gist about it. I was just messing up the derivative rules, so that's why I was getting like super outlandish answers.
Yeah, I get it. How are you doing in the class, if you don't mind me asking?
I'm doing really well,
That's
actually.
good.
It's
That's
just
good.
as soon as there's a bunch of derivatives, it's kind of it gets messy. I'm like, can I just factor this?
This is the part in the course where a lot of students, they one good, some stay doing really well and some really struggle. So this would be the time to put in that extra effort and
Yeah.
and try to because another good test grade, you're all almost 2/3 of the way there then to your final grade. So All right, so here is 6, 6, 6, 6, 6. So this time they don't give you the equation for anything. They just give you information.
Okay.
They tell you that you can read all this if you want, but there's an equation of a line y equals mx plus b. So you're used to x and y being their ordered pair, but now it's p comma q.
Mm-hmm.
So what you want to do is determine the two ordered pairs. So the first one is when the price is $2, the quantity is 9,000.
Okay.
And then it says when the price is set to $4, and then I got rid of the rest, it says sales drop to 0. So the quantity is 0.
Yes. Okay.
And this is very important. If you don't do this in the right order, you get completely the wrong answer. That's why it's sometimes good to make this mapping of like, okay, what is X and Y in this context? X is really price, P, and Y is really Q. Okay, so your slope is normally Y2 minus Y1, X2 minus X1. So in this case, it's going to be 0 minus 9,000 over 4 minus 2.
Okay.
All right, so now if it were me as a student, I would probably just keep using my mx plus b because I know that really well, and then map it back to the original when I need to at the end. So the way you find b is you use one of these ordered pairs. Now it just so happens that they give you two. You can use either one. Let's use this one on the right. So 0 equals minus 4,500 times 4 plus b. So this is 18,000. 0 equals minus 18,000 plus b. B equals minus 18,000. I'm sorry, a positive 18,000 because you move it to the other side.
Yes.
Okay, so now we put that number back in here, and we say, okay, we're not doing X and Y, we're doing Q. So this becomes Q equals minus 4,500 P plus 18,000.
Mm-hmm.
That's your demand equation. That's your part A. So if you do everything I just said, but you do it in terms of X and Y, it'll mark it wrong. It's got to be in terms of P and Q.
Okay. And then from there, you would set it now for B. You would set that equation equal to 0. Will you find the derivative first?
There's two options for B. You can either find E and set it equal to 1, or you can find the revenue and take the derivative and set it equal to 0. I would suggest finding the revenue.
Okay.
First. Revenue is price times quantity. So it's price times minus 4,500 P plus 18,000. Okay. Let me know when you get caught up to here because I want to go back to previous problem, make a point.
Yes, I am all caught up.
Okay, so we're going to distribute the P and take the derivative. And if you go back to the very first problem we looked at, we had to use power rule. We had to use product rule here because I couldn't distribute the P in because there was this square.
Mm-hmm.
These are two very different problems. Whenever there's a square there, you can't distribute it in. But here we can. Like, we don't want to use the power rule because the power rule is complicated. And if you can just distribute this in, it becomes much nicer. Minus 4,500 P squared plus 18,000 P. Because here the derivative is just power rule.
Yes.
Okay, so your derivative, much easier. Power rule, right? 2 times. So it's minus 9,000 P plus 18,000.
And then you set that equal to 0.
Yes, exactly. You got it. So P ends up equaling 2.
Yes.
That's your part B.
Okay.
Well, part B, first part. So the second part of part B, it says predict what the weekly revenue will be. So that's taking that number. And this is what's confusing because, like, which equation do I put it back in? you put this back into this equation because that's the revenue equation.
Okay.
It's not the derivative. The derivative is different. It's the original revenue equation. Looks like it's like 18,000, maybe.
Yes, I got 18,000 as well.
Excellent. I need to just step away for 30 seconds. We'll just move on to question 7. We probably have time to do another question after this, but it's up to you. So just to give me 30 seconds though, please.
Okay, no worries.
All right, I'm back.
Okay.
Okay, so 7 is really, really similar. It's like what I call same question, different numbers. So let me snip that in, and then we'll start. It's the same deal. You're going to want to find 2 ordered pairs. You're going to want to get the okay. So the again, it's like the last problem. It's P comma Q. So it gives you, it says, okay, $53, and then you get 10,000 books.
Mhm.
But then when the price goes to $78, the sales drop, and then I cut that off again. Oh boy. What does it drop to?
It says 70, it would be 53 comma 10,000 and then 78 comma 1,000.
All right. So yeah, so that's what I got here. And then to find your slope, so your slope is going to be 1,000 minus 100,000, or I'm sorry, 10,000 over 78 minus 53. So minus 9,000 over 25.
$360 I got. Negative 360.
Negative 360. Yeah, it sounds right. Okay. So now use either equation, but it's Q equals minus 360 P plus B. It doesn't matter. I'm going to use the second point. 1,000 equals minus 360 times 78 plus B.
I got BS 29,080.
Okay. 29,080 like that.
Yes.
Okay, so that gets us our final answer, minus 360p plus 29,080. Will you try that and see if it works?
Yes. 1 second. So the equation would be Q equals negative 360p plus 29,080. Okay.
Yes, it's always the equation of a line, but it's with P and Q instead of M and X, or X and Y.
Second. Okay, yes, that worked. So then for part B, we would take the revenue again. So you do P times negative 360p plus 29,880.
Exactly. So you gotta find the revenue function, which is price times quantity. And your quantity is the thing you just found. It's the minus 360p plus 29,080. And rather than finding the derivative through product rule, you want to distribute and then take your derivative.
Okay. So the derivative would be negative 720p plus 29,080
Yes,
equals 0, and then solve for P.
you got it. It sounds like you've either you're getting this, or it's finally making sense, or you're
Yeah,
like, oh, it's the same as the last one. So you're like, oh, I got it.
I just think that my professor just didn't really explain all of the parts very well. So when we got to the homework, there was a lot of problems that we didn't practice in class that showed up. So
Yeah.
I was just completely unsure of how to do it.
Yeah, so the price I get here, you said part A was correct. You tried that?
Mhm.
Okay, because it didn't work out as a like really nice price.
Yeah, I got 40.38 repeated.
Yeah, 40.39. And so because it's WebAssign, I would try that before I did the next one, just in case it,
Okay.
for some reason didn't like that.
Yes, that was correct, 40.39.
All right, great. And so now it's asking for the revenue. So it's like, well, which equation do I use? So you got to go and you got to say, oh yeah, that's my revenue equation, or the one below it. It's the same thing. These are both your revenue equations. So either one.
Okay, and then just plug the 48. I'm sorry, the
Yes.
40.38. Okay, perfect.
Yeah, 40.39 back in. And see, it doesn't say it around. That's why I was a little bit concerned, because it isn't a nice number like we want. So P. So I get 587,254.
Yes. 587,254.42 basically. Yep, that's correct as well.
Great. So we got a few minutes left here. Is there anything else you would like to cover or have
Yes.
questions about?
I don't think I think I cut the screenshot off for number 4. But going back to that one, part C asks for the revenue.
Yes, let's go back and do that. Okay, so we put so here's 4. Yes, here's 4. We found the price. The price was 11.
Mhm.
So the revenue is price times quantity. See, we have the price, so we just need the quantity. So do you have the quantity equation? Yes, you do, right here. So we're going to put P in there in that equation. So it's going to be Q is minus 2P squared plus 33P. So you're going to put in your 11 minus 2 times 11 squared plus 33 times 11 and get a number for that.
Okay.
So as a side comment, if you were to work through this homework assignment again, or if you have a review, like you will start to see that there's only a few, like it feels like there's maybe a lot of different questions they can ask. There's really not. There's only really a few that they ask.
Yeah.
And if you like do them all for a few questions, like, oh, I got it, because they're all the same.
Yeah. So for that one, I got 121.
Agreed. And so you just multiply those together. So your revenue is 11 times 121. And sometimes like when you look at this again, you might be like, well, where did this come from? So just when you look this over, make sure you're like, okay, I know where that 11 came from. I know where the 121 came from. So it looks like it's 1331.
Yes. That's what I got too. And then it
Excellent.
was correct on what the sign.
Great. Well, yeah, I assume you're a referral from someone who may have used my services in the past.
Yes. One of my best friends is Elise Jones.
Okay.
And
Awesome.
she took this class last year, and I asked her if she could help me, and she referred me to you.
Well, thank you for scheduling. I'll be sure to send her a thank you for doing that. And if you ever need a time that's not like listed on the website, I did text you. Hopefully you got that. You can always text me and say, hey, Matthew, I can't make any of those times work, but could you do this? And I'll do my best to try to put a time up that works for you.
Okay, perfect. Yeah, so I'll probably schedule another one on Wednesday because I have a test on Tuesday. I mean on Thursday.
On Thursday.
Yeah.
Do you have the WebAssign review already?
I do, and I won't do that until Thursday if you'd like. I mean Wednesday if you'd like.
Try to do as much of it as you can on your own would be a recommendation if you have time. I know you got probably lots of other classes, but if you can, try to do it for your problems.
Okay.
Cool. So I'll send you the notes and the screen recording out a little later today. And thanks so much. That's it for today's lesson.
Perfect. Thank you so much, Matthew. You have a
You're
great day.
welcome. You too. Bye now.
Bye.